Hello students, in the previous class we have discussed the reversible changes and the examples, right? The changes that can be reversed. Okay, that type of changes are reversible changes, right? You can obtain the changed substance in its original substance. Look at here. Okay, if you make a paper board by using a piece of paper, after that the paper board can be converted back to the original paper even if it is a little bit crushed. Okay, so the thing is that the original substance you will get back. So that type of change is a reversible change. So we have learned the same activity in the previous class also. And the second activity, look at here. Here what happens? I just simply crush the paper. I just simply crush the paper into unconditioned way. So what happens? The paper just crushed and only the appearance has got changed. Look at here. So is it possible to get back to the original substance? Yes. Even if it's just a crushed, you will get the paper back. So in the both the cases, what you can observe, you will get the original substance back. Paper board and the crushed paper, both the paper you will get the original one. So now you will move to the second type of change. It is irreversible changes. The changes that cannot be reversed and the change is permanent, or if you are not getting the original substance back, that type of changes are known as irreversible changes. Today we will be concentrating reversible changes and reversible changes in its more examples. Okay students, if it cannot be reversed, look at the definition. The changes which cannot be reversed. Look at here. Burning paper. So there I have made a paper board. Look at here. Here I am going to burn the paper. So after burning, what is formed actually? You can see smoke and ash is formed. Okay, so the best example of irreversible change, it is burning of paper, because you are not getting the original substance back. The substance has got entirely changed. A piece of paper, when you burnt, what happens? It is completely changes into ash and smoke because a new product has been obtained. So you never get the original paper. Okay, look at here again. Let me conclude the reversible and irreversible changes once again. The changes which can be reversed are known as reversible changes, and the changes which cannot be reversed are known as irreversible changes. In the case of reversible changes, you will get the original substance back. Now let's go to the more and more examples of reversible and irreversible changes. I will show you many more examples. That times you will be able to identify whether it is reversible or irreversible. Look at here. I have a cone ice cream. I have a cone ice cream. So what happens? When I kept it open, it starts to melt. I need the original cone ice cream back without melting. Is it possible to get back to the original state from the melted condition? Yes. You just freeze it again. You just keep it in the freezer. So that time what happens? You will get the original ice cream. Right? From the melted condition, it is converted back to the original state. So it is reversible change. And the second one. So what I am doing is, I just want to prepare the chapatti. I just prepared the chapatti by using a dough. So I prepared the chapatti. So is it possible to get back to the dough? Get back to the dough again? No, it is a irreversible change because it is already converted to chapatti. The chapatti never go back. Look at here. I just inflated the balloon for a party. Okay. So after the party, I just want to collect all the balloon back for the next party. Okay, I inflated all the balloons and I collected back. Yes, is it possible to get the original balloon when you are not inflating the air? Yes, it is possible. Why? What type of change it is? Yes, you yourself can tell me. It is a reversible change. Right? Yes, this is the best example of a reversible change. And the next example, I am using a pencil and a rubber. After continuous use, what happens? The size gets shortened. The size of the pencil and the size of the rubber gets shortened. So is it possible to get back to the original rubber and pencil? No. It's a common sense you can use. You never get the original pencil and paper because it is a reversible change. Right? Yes, because it is already converted. It is already shortened. So going back is not possible. Look at here. I just want to freeze. I just freeze the water into ice cubes. Is it possible to go back to the water again? Yes, you just take it out from the refrigerator. You just keep it in a normal temperature because it is a reversible change. Look at here. I have prepared orange juice out of orange. Is it go back to the original orange? No, it is a reversible change. Right? Yes. I prepared curd from out of milk. Is it possible to convert back to the milk? No, once it is set because it is a irreversible change. It cannot go back to the original substance. And from the salt solution, look at here, from the salt solution, is it possible to convert back to the salt? You have learned this activity in chapter 5. Yes, if you keep it for the evaporation, it will go back to the solute, right? Since it is a reversible change. Best example of a reversible change. Look at here. I have used these ingredients for making those food items. I just prepared omelette. I prepared pudding also. So look at here. It is not possible to go back because it is a irreversible change. Here what I did, I have taken the raw dough and I just rolled it. The raw dough, I just rolled it in a chapatti maker. So I just want to get back to the raw dough ball. I just want to get back. Is it possible? Yes. Here you will get the raw dough ball because you just change the shape. You are not cooked it. So because it is a reversible change. The best example of a reversible change. And burning of agarbatti, ash and gases are produced and the size is shortened. You got a new product once you burn any substance because it is an irreversible change. It cannot go back. Ripening of fruit. Look at here the 3 stages of fruit. This is the first stage, this is the second stage, and finally it is the final stage. It is a irreversible change. Okay students, I hope you have learned the differences between reversible and irreversible changes. Now we will move on to the next session, that is expansion and contraction. Okay, what is the role of expansion and contraction in this chapter? Did you think? Yes. Expansion and contraction. When an object is heated, it increases in size, which means that it expands. And this is called expansion, which means that on heating, what happens? The size increases. The size increases and it is called expansion. And what is contraction? The decrease in size of an object on cooling is called contraction. Look at here how they both are connected. So expansion occurs on heating whereas contraction occurs on cooling. The expanded objects can be contracted when you cool the object. Okay, I hope you get the connection. So how they both link? What sort of change it is actually? It is a reversible change because expansion is a reversible change because once it apply the heat, it gets expanded. When you cool it, it will convert it back to original condition. That is why you can say that expansion is a best example. Expansion means heating is a reversible change. Okay students, in your textbook there is an activity that is in page 48 6.2. Look at here. So how the soil digging tools are being constructed? First they are prepared separately. First the wooden handles are prepared separately and the metal blades are prepared separately. Finally, they are fixed together and they prepared a digging tools. Okay, so iron blade is fixed on the handle. Okay, such a way they have been prepared it. Okay, how iron blade is fixed with wooden handle? Yes, the ring present in iron blade is made slightly smaller in size than wooden handle. Okay, when we want to fix the handle, iron ring, you just heated it, just to heat it up. That time what happens? It get expands, right? On heating the iron get expands. Did you all go to blacksmith? When you go to blacksmith, you can see what they are doing. On heating, it get expands. So when it expands, what happens? They are fixed the handles into the expanded area, right? Now the handle is easily fit into the ring. When the ring cools down, it contracts and it fits tightly onto the handle. So here we are using the application. That is, it is a big important change, important reversible change. Best example of a reversible change, because after contraction and expansion, you can make this. Look at here. Fixing metal rim on wooden wheel. How it is possible? Here also the same principle. So metal rim is made slightly smaller than wooden wheel. So the rim is little bit smaller, right? Yes. On heating, what happens? The rim which is made up of metal, right? On heating, the rim expands and easily fit onto wheel. Okay, then we pour cold water over the rim. That time what happens? Yes, it's get cooled and it's get contracted. And finally, what happens? The rim fits tightly on wheel. This is how the rim wheel and the wheel is fitted on the, the rim is fitted on the wheel. So contraction and expansion is used over here. So we can bring changes in a substance by which method? Yes, you can see, let's move forward. So there you will come to know how the changes can be taken place. So either applying force, or you just heat the substance, or just mix it with some other substance, or just applying pressure. Such a way you can bring the changes.